we're trying to teach something to the machine, right? We need to give it the right information. Otherwise, it'll learn improperly and you won't get good results. And that's what we've seen as well. A lot of people will kind of haphazardly upload their data sets into the Newton platform, just click run, and then they come out with a poor quality model. And so, our support team will go back to them and help them, understand the data a little bit better and reformat it so it'll work better.
And imagine how much time has been spent from your client side and your team side just trying to fix that could have been saved had they done that in the beginning. And also, unfortunately for you, they don't realize that it's their fault. So they think it's the tool, and it's actually not the tool at all. It's them and their data.
Yep, and that's definitely a headwinds we've seen as well. Hey, I used Newton, I created a model, it wasn't very good. Wow, this tool sucks.
It's easy to blame someone else, yeah.
But when we go back, we clean up the data, we can actually get a really good model.
Yeah.
So
you've got an amazing tool, and yeah, you just need that great data behind it to power it.
Cool. So I think that is a nice leeway. I just have a slide for all of you to kind of showcase what we do with our automated data pre-processing. So after everything that Susan has shared us, once you've got the data prepared, let's take a look at how Newton can help you as well. Once again, thank you, Susan, so much. And so when we look at a data set, as Susan had showcased, there's a lot of different things that are going on. So in this particular case, we've got our client IDs and some various different information. And so what are some of the things that Newton can help with? So in this case, columns with 100% unique values will be dropped. So, an ID like columns, for example. Columns with a constant value will be deleted. So in this case, all of these values are 1. So this isn't going to help us when we create a machine learning model. Additionally, an identical column will be dropped after scaling. So you can see that the value in column 3 is doubled value of column 2. So here you can see that the column is doubled. So this won't provide value. And then also Newton will help handle missing values. So we'll create machine learning models to fill in these missing values. Then also in different cases where Susan had highlighted, hey, in a particular column, we might have this error, right? We have somebody accidentally keyed in some letters as opposed to the numeric values. So we'll go ahead and detect those, remove them, and then predict on a new value. And then also another issue with missing values, if there are too many missing values within a particular column, if there's more than 50%, we'll just automatically drop those. And then finally, we will have rows with these different outliers or numbers that aren't fitting within the data set. So here we have these huge numbers where in the target we have maybe 5,000, but here we have a very large number. Same thing here in column 7. We have 2, 4, 6, 8, but then all of a sudden we have 10,000. So this won't be very useful for us. So we'll go ahead and jump into a live demo example. Here's a QR code to try the Newton platform for free. We have lots of different preloaded data sets in there for you to try out across different industry verticals. Today, we're going to be looking at a famous data set for predicting house prices in Boston. And so let's go ahead and jump into the platform. So this is the Newton platform. It's completely cloud-based, so you can leverage it via the web. And all of my solutions that I've created here are tile-based, and everything's on Google Cloud Platform. So all of the infrastructure is handled automatically. And all we need to do to get started is we go create new solution. In this case, I'm going to do house price prediction. So we're going to look at all of the different features within the Boston market about houses, whether they're multiple stories, how many rooms, how many square footage, and then the historical price for those houses. And then that way, as a realtor, for example, when I'm looking at new information on houses, I can take this model and then predict on what the new house price should be. And then there's some data and analytics involved as well. So once I've done that, I can either upload my data set, I can select from storage, or use a preloaded data set, which I'll do for the sake of demonstration. So here, if you, when you log in, you'll be able to get access to all of these preloaded data sets to try out the platform for free. In this case, we're going to do a house price prediction. And before I continue, I just wanted to show you kind of what the data set looks like. So here we have information about zoning, what the lot frontage is, the lot area. As you can see, we even have text data, right? So all of this is going to have to be taken care of before we create a machine learning model. As you can see, there's lots of information about the houses. And then finally, we have the historical house price of the actual value of those houses at the time. In this particular data set, we have about 1,400 different houses that we're going to learn on. So now we just hit OK. So within Newton, there's 3 easy steps for you to be able to create these powerful and predictive models. And we'll be able to look at this as well. I see some chats coming in here. I'll definitely address those at the end. So yeah, there's 3 easy steps: data set, then we train, and then ultimately we want to predict what the new house prices are. So the last step in the data set tab is we select the what we're trying to predict and train on. So in this case, we're going to want to predict what the house price is. Now, the next step is training. The platform has understood that it's regression, and the metric is root mean squared log. So in this case, if we weren't using a preloaded data set, we would be able to select different task types, but for all intents and purposes, you don't need to, and then you just click training. Now what this is going to do is it's going to begin to learn on all of those. First it's going to do our automated pre-processing, which I just showcased in the PowerPoint. And then also, if you want, you can get a text notification of when the training is complete. Once it does the pre-processing and feature engineering, if you want, it'll then train a predictive model. After that, you can go ahead and start predictions. In this case, it may take a little bit of time to train the model. So what we're going to do is I've already pre-trained on this data set. So let's just take a look here. So this took about 8 minutes to train the model. And we looked at the data that was before pre-processing. Let's take a look at what it looks like now. So after the automated pre-processing, as you can see, it's actually changed all of the text into numerical values. It's filled in the missing values, etc. So that's kind of what the data will look like after the automated pre-processing. We've also baked in some analytics tools in order to help you understand the data, maybe before you do the prediction. So in this particular case, what we have here is our exploratory data analysis. We'll give you a nice snapshot of your overall data. So in this particular case, the maximum house price was $755,000, the minimum was $34,000, and the mean was about $180,000. We can see we had 1,400 rows, 81 columns, etc. In this particular case, we had about 7,000 missing values that we've been able to handle, or about 6% of our total data. In addition, we also provide what we call continuous data. So On this particular case, we're looking at the general living area distribution in relation to the target variable. So what does this mean? So within houses, right, we have a general living area. And so in this case, most of the houses fell under about 1,200 square feet for the general living area. And on the right here, on the bottom, we have our general living area, as well as the house price in the vertical. So you can actually see somewhat of a linear, actually pretty well linear relationship of the larger the general living area, the higher the house price. And you can do this with all of the different features as well. Some cases it might be informative, in some cases it might not be. We also provide information on the discrete data. So this is kind of a nice snapshot of the categorical data, if you will. So in this case, it was, did the house have central air conditioning or did it not? So 1 or a 0, or a yes or a no. In this case, a large amount of the houses did have central air, and a few didn't. And then on the right, if we look at it in relation to the target variable, we can see that quite a lot of the houses that did not have central air sold for under 180,000. And then houses with general or central air, excuse me, they sold from all the prices up to 175,000. Here, this is a violin plot. So here we can see the general distribution of the sales prices. And then all of these outliers, say some of the houses that sold for 750,000, we actually remove those automatically in the data pre-processing. We also provide a correlation heat map. This will showcase all of the features that are correlated with the target variable, as well as different features. So in this case, the overall quality of the house was highly correlated with the sales price. If we look here, we can see the first floor square footage is highly correlated with this particular feature as well. And so in this case, certain features that are highly correlated, we might want to remove. One of the other kind of cool visualizations that we have as well for your data analysis is the missing value heat map. So this is actually a snapshot of the entire Excel sheet. Anywhere there's white, there's missing values. And so here it's a little bit easier to see. So for the feature alley, you can actually see a lot of missing values, which are white. And then for some of these ones that are darker, are a lot more filled in. So we might want to say, hey, you know, we don't have much data on the alley. So maybe there's other areas we can go and collect data to fill this in to create a stronger model. And then we also show some different outliers and then the overall model quality. And in this case, we use RMSLE. And if the arrow's down, then you want a lower one. So this is pretty low, so that's good. So that's our exploratory data analysis. But of course, what we all wanted to do here is make predictions, right? Because we have all of our historical data, we had the target variable, but now we want to predict on that. So you can just click this button to enable prediction. I've already done it just to, because it takes a couple of minutes for demo purposes. You can download the solution and deploy it on a machine or on an edge device. You can also access it via REST API. So if you want to make predictions every month, you can set up and call to the cloud. And we provide the sample code that you would need to do that. So you really, you don't need to know coding. And as you can see, all I've done is a couple of clicks and I've been able to create a predictive model. No code necessary. So once you want to do predictions, you click start. And then right now, I'm going to select my test data set. So there's two data sets, the one with all of the historical data, including the sales price. And then there's all of the new data that does not include the sales price because we don't know. So now we're going to upload that and predict on it. So normally you would just click start, but I've already created predictions. And so let's see what the Newton platform has produced. So in this case, everything to the right is all of the data that we've uploaded, the new data that we want to predict on. And then everything left of this area is the new predictions that Newton has created. So in this particular case, for the first house, we've predicted this 130,000. Now, once you've done a prediction, you may want to understand, why did my model make that prediction, and what are the things that I can do to help with that? So in this case, maybe we want to look at house number 4, for example. It predicted at 179,000. We can use what we've created, which is our model interpreter. This will allow you to understand the prediction from compliance purposes, or even from business outcomes. What can we do? So here we have all of the top features that are influencing the predicted value. So in this case, we predicted the house to be 179,000. Now, one of the features we have is the overall quality of the house. In this case, this house was rated as an overall quality of 6. Now, if we were to adjust the overall quality of the house to an 8, now we would predict the house would sell for 219,000. So if you think about it, as a realtor, what are the different things I can do in order to improve the overall quality of the house to ultimately get a higher sales price? And is the investment of raising the house quality from a 6 to an 8, am I able to invest, say, $10,000, right? So instead of 180,000, it would be 190,000, but I can actually sell it for 219,000. So that's just kind of a little bit of an example of how you might be able to, look at the data, make adjustments, and then make business, actions from that.